Right, so our erosional landforms. So just like with rivers, with coasts, sorry, rivers have different erosional landforms and they have depositional landforms as well, which we'll get onto another day. But we're going to start with our erosional ones. These are the ones that are created simply by taking away material. So they're purely based on erosion as to why they're there. I'll set this one up because it's quite a complicated diagram to draw. There are some better, more simple ones that you can find on the internet, so have a little look around. But interlocking spurs, they only happen in the first initial stages of our river, so right in our upper course. So this, for example, could be the source of the river, right up here. So right up in the highlands, somewhere where the water first springs from. And what happens is the river will start to, as we said, will try and work its way down to the sea. It'll try and get there in whatever way it can, whichever is easiest. And it's concentrating all its energy on eroding vertically. But sometimes the rock that it's attempting to erode through is just too resistant. So what we get in mountainous areas in particular are these kind of big, really resistant, hard to erode rocks that form these kind of hill slopes. So what the river decides to do, rather than trying to vertically erode through the middle of one, is it will take the lowest down path it can, and it will actually end up weaving its way through these big outcrops of hard rock, where we get one kind of hill slope interlocking with another hill slope. So this kind of V-shaped bit right here, that is what we call an interlocking spur, because these hills here are called spurs, and where they then kind of interlock in this V shape, hence the term interlocking spurs. So a river will erode through highlands in the upper course of a river, and as it encounters these big outcrops of very hard resistant rock, it simply weaves its way around them, and the resulting landform where these two kind of hills meet in a V shape is called an interlocking spur. So labels you should be putting on here is so interlocking spur, we mentioned that we get this V-shaped valley, so that's probably quite important to put on there too. V-shaped valley. Obviously this is our sort of river bank over here at the sides of the river, and you've got your river channel down here, so make sure you label your river channel as well. And that's it for interlocking spurs. It's quite a quick one to explain. So going on to our next one, I'd recommend having a look at some photographs of this because the diagram doesn't really do it justice. So we'll now go on to having a look at rapids. So there we go. Rapids are quite, I guess they're quite a fun part, aren't they, of a river? It's the bit, if you've ever been whitewater rafting, that's the bit that you raft through. So it's bumpy, it's got turbulent water, it's going to have all this big white spray. But you'll notice it's not like, you know, we draw these nice rivers with these nice flat riverbeds. It's obviously not going to be like that. So what we tend to find with rapids is we tend to find alternating bands of hard and soft rock. So again, this might sound familiar from what we did with coasts when we looked at headlands and bays. So excuse me. So if we get a situation in a river where we get these alternating bands, so let's have a, I don't know, that's our hard rock, and in between is our soft rock. Let's put a H on that for hard, and an S on here for soft. Now you can guess, as the river is travelling over these bands of rock, which ones is it going to erode faster? Common sense says that our softer rock is going to erode faster than our harder rock. So what that ends up with, if we're to try and attempt to make this in a bit of a 3D diagram now, see, look at that for art skills, eh? So these kind of bits end up jutting out, and the softer rock ends up being eroded. So as you can see, as the river now travels, as if the water's now travelling over this, it's going to go up over the mounds of hard rock, down into these sort of dips of softer rock, and then up and down and up and down again. And you can easily see why we then get on top of, if you look at the surface of the river, kind of the water's, you know, doing all of this and you get all this spray. And again, if you're going whitewater rafting on this, it's obviously great fun. It's all because you get these alternating bands of hard and soft rock on your riverbed, creating this turbulent water that then travels over the top. That's it for rapids. These are quite quick and easy, aren't they? They're not as complicated as the coastal ones, thank goodness. So some sort of diagram a bit like that would be absolutely fine for rapids. And finally, so I said they're a bit easier, didn't I? I get to waterfalls, which aren't quite so easy. So one thing you learn about at A-level is something called a nick point, which, how to put it simply, if we're to get a change in sea level, a river that goes out into the sea on a high tide would have its water levels change, and that creates an erosional process that kind of just works its way back up the river. If a nick point gets big enough, we end up with something called a waterfall. And it's usually, again, where we get some differing bands of hard and soft rock. So I'll attempt to make that make sense. You don't need to know about nick points at GCSE. It's just something I like to mention, because when you then go on to do it at higher levels, it kind of makes more sense that someone's mentioned it once before. I'd recommend Pathway 1 and 2 perhaps go and have a look at nick points. They're spelt like this with a K. And they're river features that end up resulting in waterfalls. Pathway 3 and 4 completely ignore nick points. You don't need to know about them. To be honest with you, Pathway 1 and 2 don't even need to know about them. It just might be interesting for you to have a little look at how they then form waterfalls. But so the nick points will eventually form the beginning of a waterfall, but just ignore that for now. You don't need that bit for the GCSE version. So just pretend the waterfall's kind of already there, because that's what you sort of need to know. I'm going to draw this in stages of diagrams, just attempt to make it a little bit easier. And I'm going to do it from kind of a sideways view. So again, let's make some, that's going to be our hard rock on the top, and we're going to have softer rock underneath. So again, we're talking about it differently now. So where with the rapids, the hard and soft bands were kind of vertical, like that, going hard, soft. With a waterfall, it's the other way around. So we've got hard rock layer on top with a soft rock layer underneath. They're now horizontally aligned. Those of you going on to do geology will learn all about that in geology. And here's our river coming across the top, and as water does when it gets to a waterfall, it then kind of drops down quite dramatically, and then our river would carry on flowing from there. So that's our start point. So we've got hard rock, underlying soft rock underneath, and our river is travelling across, plunging down into this bit here, and then going on its course. Now over time, this water, by the process of hydraulic action, so try and get your key terms of different types of erosion in here, will start to wear away this soft rock underneath here, and you can probably guess what our next diagram is going to end up looking like therefore. So try and get enough in there. What tends to happen is we get this big overhang. So again, let's put our hard rock up the top there. So our river is still coming over the edge, still plunging down into this section here, which we call the plunge pool. We'll label them all in a minute. But because, and again, you're going to get loads of spray here, so it's going to be chucking stuff up. You're going to have little pebbles in the bottom, which are going to be dislodged and start to abrade this even more as well. So we've got hydraulic action and abrasion. Pebbles will be hitting each other as well, make each other smaller. So we've got attrition there too. And it's going to undercut this soft rock here, leaving quite a big overhang section. And again, we talked about overhangs when we talk about cliff formation in coasts, so you can probably guess what's now going to happen. So at some point, this overhang of rock becomes too sort of jutty outy without any support underneath, and it's going to fall away. So this section here will eventually fall into the bottom of our river channel at the bottom, because simply the overhang became too great. So we're going to end up, if I kind of draw like a stage diagram, let's do like a jutty out bit there that's quite small, We've now got a much bigger section down here because we've lost lots. And over time, of course, this overhang is going to be lost periodically. So that's kind of the original bit of our hard rock, and actually this is now what's left. Can you see what eventually over time happens to waterfalls? They retreat backwards. So where our original waterfall was over here, it may now be over here. So waterfalls over time, don't know if you knew, they will move backwards up the stream. So now for labelling, and of course our river's now going to be coming down here, isn't it? Falling into the water. Again, pebbles in the bottom. Remember, once this bit falls into the water here, you've added more rocks and bits of material, which means that abrasion's going to increase too. So each different stage is actually going to make the erosional process worse, if you like. In terms of labels, there's a few things you need to label on here. Obviously, first of all, you can label this bit as the overhang. We mentioned that. Obviously, make sure you label the hard rock and the soft rock on all of your diagrams. Obviously, in your description, make sure you mention that the hard rock won't be as eroded anywhere near as fast as the soft rock. But once kind of gravity's in play and it's been completely undercut, it's eventually going to collapse under the weight of itself. And then this bit here is the bit, it's a kind of classic, so it's meant to be an N, feature of a waterfall. We get what's called a plunge pool because the water plunges into this and creates a big wide pool because of all the different types of erosion going on. Obviously, make sure you get your erosion types in there as well as your labels. So we've got abrasion happening from the pebbles down here. We've got hydraulic action from the force of the water as well. You can mention the fact that attrition is going to make these pebbles smaller over time, and we'll lose some of those downstream as well at the same time. That's about it. The only other thing you do need to know, and I'll do a bit of a separate diagram, attempt to do a bit of a separate diagram. Whenever you get waterfalls retreating backwards, and you'll get the formation of what's called a gorge, because, let me go like that. Let's put the river in the bottom. It's not a very good diagram, I'm so sorry. But as the waterfall retreats backwards, the sides, the riverbank, aren't really being eroded. All the erosion that's happening from a waterfall, again, it's lots of vertical erosion. The water is plunging down into the plunge pool and eroding downwards, and it eventually retreats back up. Now, if you imagine the waterfall like used to be here, and it's eventually retreated back and back and back. Imagine my diagram is in some way 3D. What will get left behind are these really steep-sided gorges, and the waterfall eventually might not even be visible, but you're left behind with these big, steep, almost cliff edges. So again, if you're doing any extra reading about this, formation of waterfalls, as they retreat backwards, as the top bit collapses, you will get these steep-sided gorges left behind as well. So a bit of an additional feature that goes with them. Hope that all makes sense. There are loads of really, really good revision sites that cover these in quite a lot of detail, has some nice diagrams that are quite easy to copy, and has some nice explanations along with videos and things like that, so you can kind of see how it's forming and what they look like in real life. So do have a little bit of a search. Obviously, hope the video helps, but there is plenty of information out there. Just Google waterfall formation GCSE or rapid formation GCSE. You'll get a whole load of stuff. But any problems, as ever, give me a shout.